Hey there, Math 9, Lesson 3.3, Order of Operation with Exponents. We'll get right into it. You should have seen Order of Operations back in grade 8, if not earlier. And the Order of Operations are sort of the when you do what in mathematics series. Pop this up a little bit here. You might remember them referred to as the Bedmas rules, sometimes known as the Pedmas rules instead of B for brackets. In some other mathematical systems, they talk about it P for parentheses. It's okay. We're going to go with Bedmas. It's a good rule. We're not going to change it. So, first rule. We'll fill this in. The order of operations rules state that brackets are super important. So, if you saw, for example, 5 multiplied by 3 times 2, you would have to do what's inside the brackets first and then multiply it by 5. Brackets are considered higher priority than exponents, which of course leads me into my next point, exponents. If in this case we had 4 squared, if we had this, for example, really exponential notation, when you look at exponents, it's repeated multiplication. You have to take that on right away. You apply the exponent, you would need to do the 4 squared first before you did this next half of the mathematical operation. Division and multiplication are next most important, so this would be most important at the top, and this would be least important, or sort of lowest priority, at the bottom. And we'll throw in addition, subtraction here. So if you had, let's go back to the division multiplication example, if you had 5 to the third power increased, let's say 15 divided by 3, there we go. Just change pen colors here. In the Bedmas rules, of course, exponents would be the most important. You'd have to do this. But then you would have to do this as your next operation. You couldn't be adding the 2 to the 15 because division and multiplication are higher priority than anything that gets added or subtracted. Quick addition subtraction rule. Pop out to that. Back to purple. If you had 5 times 2 minus 1, there you go, that should be 10 minus 1. Your answer should be 9. But you have to be very careful. If you do this incorrectly, that's the part you must do first. But you could see how the answer could be very different if you multiplied 5 multiplied by 2 minus 1. Well, the answer you would get would be 5. That would be totally incorrect. So, you need to do your Bedmas operations in the appropriate order. In this case, this would be first, and then you would be finding whatever the answer is and decreasing it by 1. I like to draw the squares around it just to give you an idea of what to do. Going back just a little bit, since we're going to be doing work involving coefficients, I should back up and say what a coefficient is. And I think a common coefficient that you would have seen would be from your algebra experience, say 2x squareds. I refer to coefficients as sort of counting numbers, how many of something you're talking about. So I'm going to use this term here, an x squared, and I'm going to say there's 2 of them. Now what's the of them? Well, there's two x squareds hanging around. So if it was like the zoo, you'd say, oh, look, two zebras, or look, two giraffes, or three chimpanzees. I think you get the idea now that what this is, you do multiply with it, but it really tells you how many of something you have. So in the example below, I'm a little more comfortable running with it now, you could say that your coefficient is allowed to be negative. This really means negative 5 times 4. The coefficient sits out front like this, and it's implied multiplication. By saying that there's two of them, that's like saying you've got an x squared here and another x squared here. Well, you count the giraffes, there's two x squareds there. And in this case, you have three of those chimpanzees. When you look at it, you know you have three of them. So coefficient, an of them number, a counting number. And it can be positive or negative. When you look at this example, you'll see that the coefficient is often written in front of a number with parentheses. They're checking to see if you're aware of the Bedmas rules. This is 5, come back here, 5 multiplied by 3 to the third power. This is 5 times 27. 3 times 3 is 9, times 3 is 27. I'll let you crank that out on a calculator, but that's the idea. In this case, the coefficient is 6. 6 multiplied by, now careful, it's negative 5 times negative 5. 6 multiplied by, now these negatives cancel out. When things have the same sign, when they get multiplied, you get a positive answer. 6 times 25. Now, if you think about that, quick way to do that if you wanted to know the standard answer. Well, 4 quarters in your pocket is $1, so this would be like $1.50, 150. Use what you know, it'll help you mathematically. This is an interesting question. This is 4, let's write it out in full form. This is 4 multiplied by the negative of, now I'll write it so that you can see it. There we go. It's 2 to the 4th power, so the base is 2 to the 4th power, and that sneaky negative makes the answer negative. It's like multiplying by negative 1. So that would be 4 multiplied. Now this would give you 16. This is like 4 multiplied by negative 16, which is interesting. You would get a negative answer since the signs of the two things multiplied are different. Now I'll let you pop out the answer to that on your calculator, but I really do want to impress upon you this point, that that negative right there that I just highlighted takes the negative of whatever 2 to the 4th power achieved. A way to think of it is 2 to the 4th power is the exponent. It's the most important thing you have to do, and the negative of is multiplication. You just multiplied that wonderful positive 16 by negative 1. It's very different than the example that we saw up here, because in this case, this minus 5 here is inside of parentheses, which means it's very, very clear that it's that the base is a minus 5 being multiplied by itself. And when you see the parentheses, it totally clarifies what's going on. That is very different. Very different than what you saw here. See how the negative sign is in inside the brackets, and so is the exponent, that's what tips it off right there, that you're going to get a negative answer. Awful, isn't it? It's just Bedmus. All right. Let's switch colors to, oh, I don't know, blue now. This is -7 multiplied by 4 to the third. Well, that's 64. And again, I invite you, crank it out on your calculator. I'll leave that to you. Writing each expression. If you had to say how many of something you had, this one's kind of interesting. What's the repeated multiplication? Well, that's 3 to the third power, and that's happening 4 times. As soon as you see the first example, it becomes, I think, readily obvious what's going on here. The repeat multiplication, in this case, this is a -2. Let's put it in brackets because it's definitely the base, and it's being multiplied 1, 2, 3, 4, 5 times to the 5th power. And since this, we've got a leading 5 out in front, it's 5 times whatever that answer is. This is 10 to the 8th power. So using these brackets, you can be very definitive. But no matter what that comes out to, that -1 is going to ruin all of that multiplying. We had a nice positive answer, and then we took the negative of the value. Now, this will definitely give you your answer. You could also say -10 to the 8th, like that. That's the same thing, because you're taking the negative of 10 to the 8th power. There's your base doing what it's supposed to, and there is the negative coming along afterwards and doing a number on the whole thing. We don't write -1 like that. When a coefficient is 1, if it's +1, we don't even write it, and if it's -1, we just say negative of the value. There we go. Let's change the color here to, oh, I don't know. How about nasty burnt orange? 1, 2, oh, need markup. There we go. 1, 2, 3, 4, 5. So this is -10 to the 5th power. Now, because it's -10, I'll put it in brackets, and it's being multiplied by 6, so its coefficient is 6. Evaluating these using your calculator can take a little bit of work. I'll just look at 2 of these, and I'll show you quickly what the calculator answer would be to those ones. I'm going to pick in particular on, let's say, A and D. The -6 is going to be multiplied by, might as well put in the sign, 4 times 4 times 4. You see how this can take up room. This is why we use the exponents in the first place. Okay, so if you're on your calculator, I'll pop out to a calculator that I have built into the iPad, show you what that answer is. There we go. Easiest, I always find it easiest on an iPad to do that. There we go, Calculator Pro. And let's go to just sort of some standard calculator work. There we go. And I have to remember what our value was again. -6 multiplied by 4 to the 6th power. Okay. So because you can multiply in any order, I'll just say 4 to the 6th power is, and then I'll just multiply that by -6. There we go. And it's interesting how that little triangle that between the 4 and the 6, that it's called a caret. It means 4 to the 6th power, so 4 times itself 6 times, and then I'm just multiplying by a value. So in this case, the coefficient is -6. There we go, negative 24,576. Again, you get the negative of the answer. Sneaky down here in section D, I'm going to zoom in on this so I have lots of working room. This again is one of the questions where you have the negative of the answer. The answer will be negative because you have to do this part first. 7 to the 4th. Exponents are higher priority than taking the negative of. That negative of is multiplication. It has to be done second. So to clarify, make it really make sense, change color, you have to do this first, and the negative of is multiplication. That is lower priority, second. So if we pop out to Calculator Pro, I don't have 7 to the 4th memorized. 7 to the 4th power is this, and then you have to take the negative of, well, that's the same as if I pop a minus sign in front of it. 7yx to the 4th power, there we go. So our answer would be negative 2,401, pardon me. Voila. Now below what you have are what we call the Bedmas rules. So you have to decide, well, what is it that you have to do first? Well, kind of helps if we write Bedmas along the side here, just to remind ourselves. And then I like to link these, just so we remember. We do those as they come up left to right, and that the most important stuff is at the top. So when I see a question like, let's switch here, 4a, I know that I have to do this first because brackets are more important than exponents. So 9 squared less 21, 81 less 21, that's a nice number, should be 60. Okay. In your subsequent examples, there's exponents here, that's 36, and then you figure out the exponent of that, which is 25. 36 less 25, 11. So you couldn't subtract until you had done the exponents. You have to really pay attention to your order of operations. Sometimes it can catch you. It's the -4, which is going to the 2nd power, so you get a positive 16. And in this case, just go ahead and write the sign, and then figure out what the value is. I always write the sign in, and then, if necessary, change it later. -3 to the 3rd power is -27. There you go. If you were careful, you wrote your original minus sign, you know that a minus minus is just a plus. So you can just do that. And you can happily add this and figure out the rest of the answer. 5 to the 3rd is 125, less 4. 2 to the 6th power, we'll be sneaky there. We have to go inside the brackets and figure that out. And it's the negative of whatever 2 to the 6th power is. We've seen this come up a couple of times now. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, and one more multiplication, 64. So what we've got is -64. Now when you go to do your work, it's 125 decreased by 4 multiplied by negative 64. Just do that off to the side. 64 times 4, just quick. There we go. Negative 256. Again, it's a double minus. And I always tell my students, when you're asked to go left on the number line, all you can do is go left. What the heck is a second subtraction supposed to mean? You're already going left. That's like being told, well, no, go to your other left. Well, the only other way to go on a number line is right. So a double minus cancels out the original intent of going negative, and you get addition. You're heading, if you're not heading left, you got to be heading right. Go. And there's several more examples here. These are try examples. I'll give you a chance to get your feet wet on a couple of these. They're no different than what you're seeing in example 3. They're just seeing if you can pay attention and work these out. Pause the video for a second and see if your answers and the way you're setting these things up is like the way I will write them out. So I'll get you to press pause there for a second. Okay, assuming you pressed pause at all, I'll show the setup on just a couple of these. I went after Bedmus with that example, and it will be 12 less 48, which should be, last time I checked, negative 36. Here we have brackets within brackets. That doesn't really worry me. What I know is I have to go inside the brackets before I do the exponents. 9 decreased by minus 2. That's 9 plus 2. That's a double minus right there. So I'm inside the brackets because brackets is, according to our rule, highest priority, right? This is 11 squared plus negative 3 to the third power. Eleven squared is 121 plus negative 27. Okay, I'm out of room. I'll let you take that a little bit further. Again, I'm paying attention to the brackets. They're my highest priority. And then I'm going after the exponents. 36. And I'm going to look at this right away. I see brackets, so I don't have to deal with it. I'll just write what that is. I'm going to, it's a rare time I'll combine two steps, but for space I'll just do it. 64 less 36. There we go. Here we go. Minus 5 squared. So that's the first part of that question. The second part of the question, let's see if I can zoom right in here, would be to finish this off, which would be 36 less 25 plus 64 less 36. If it doesn't come to you right away, nothing wrong with doing this. Oops. $28. And that right there is your final line. That's all you have to solve for. Example number 6. Two to the fourth power, 2 times 2 is 4, times 2 is 8, times 2 is 16. That's what that should come out to. This should be 4 multiplied by 3 times 3 is 9. There you go. 10 to the third plus 10 to the third, don't be fooled. This will catch a lot of you. This is 1,000 plus 1,000. You've got two 1,000 values. They're just being written in exponential form. Your answer is 2,000. That's very different than this. This example will catch you off guard. Because this is, you have to do the brackets first. So you've got 20 to the third power and 20 to the third power gives 8,000. Sneaky. At first glance, a great number of folks will look at that and think that these two in B would be the same. I'll make sure I wrote that down right. Yeah, that's right, 8,000. There we go. 2,000 is not 8,000. So it shows just how important it is to do your internal bracket work first. So you're just looking at comparisons here. Let's switch up colors. With brown. You have to do what's inside first. This is 15 to the second power. This is 25 times 9. Well, here's an easy way to figure that one out. 25 times 10 is 250. You didn't do 10 multiplications, so you could think of, well, what's 250 decreased by one value of 25? Oh, that would be like 225. And lo and behold, check it out. Oops. I think my value is too large. 25 times 9. 25 times 9. 25 times 9. There we go. 225. I slipped in an extra 5 there. That's why you can't trust calculators. If it seems odd, you have to look at it, even if it's late at night. This one here, 15 squared, is 225. So I want to point out the difference between the last two examples. These were added, and these were added. Now this, if you look at C below, this is power of a power. And if you remember, power of a power stated that two values when multiplied, let's say A times B to a power of n, the power of a power rule stated that the internal exponents could be raised or multiplied by whatever was to the outside, a to the n times b to the n. Now that might look like fancy formula work, but what it really just means is, zoom in here, it means that because these were multiplied, you could take the exponent. It's totally legit to do this. There we go. And I'll write the powers in there. This is like making this 5 to the second power multiplied by 3 to the second power. If we scroll over, that's exactly what this is. So the answers should be the same because it's following the power of a power rule. And that only applies when we're looking at multiplication of items inside the brackets. If you recall, the exact name for this, I've been calling it power of power because that's really what you're looking at. This is power of a product. That's just a type of power of a power, if you look back on our previous example. And it's the reason why your answer turns out the same. You got 225 here, and you got, push that over, get out of there, 225 for the answer here. So it's just the application of that rule. Point is, don't be fooled. This was addition, and the power of a power rules do not apply under those circumstances. Okay, so that was 2.3. I wanted to get that up on YouTube because for some reason it was missing. The questions are at the very end of this section, so even if you left your book at school or uh, you didn't scribble down what your questions would be, um, well, as long as you can get a hold of a book, you can get on to this. And I'll leave it there for a moment. And that's the end of 3.3. Have a good one, folks.